Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. What are some of the key features and benefits of using Pydantic in Python development?
Pydantic offers several key features and benefits in Python development. Let me explain a few of them. 1. Data validation. Pydantic provides a convenient way to define data models with type annotations. It automatically validates and parses the input data, ensuring that it conforms to the defined data model. This helps in catching errors early and preventing invalid data from causing issues later in the code. Are you ready? 2. Data serialization and deserialization. With Pydantic, you can easily serialize Python objects to JSON, YAML, or other formats, and deserialize them back into Python objects. This makes it effortless to convert data between different formats and integrate with external systems. 3. Automatic documentation generation. Pydantic can generate detailed documentation for your data models based on the defined types and annotations. This documentation includes information about the fields, their types, descriptions, and any validation rules applied. It saves developers time by automatically generating documentation that might otherwise require manual effort. 4. Easy integration with Apis. Pydantic plays well with Apis and frameworks like FastApp. It simplifies the process of handling incoming requests and validating request payloads. By defining Pydantic models for the request and response data, you can automatically validate the data and ensure its correctness. 5. Type hinting and ID support. By using Pydantic, you can leverage the power of type hinting in Python. Pydantic models provide type annotations that help in catching type-related errors early during development. IDs can also provide better code suggestions and auto-completion based on the defined data models. In summary, Pydantic's key features include data validation, serialization, documentation generation, AP integration, and improved type, hinting, and ID support. These features contribute to more reliable and efficient Python development by catching errors early, simplifying data handling, and enhancing code quality.
That's a comprehensive explanation of the key features and benefits of Pydantic in Python development. Thank you for sharing. I would like to delve deeper into the topic of data validation in Pydantic. How does Pydantic handle data validation? And what types of validation rules can be applied to the data models?
Pydantic handles data validation by using Python type annotations. By defining the expected types for each field in a data model, Pydantic automatically validates the data against these types. Pydantic supports various validation rules that can be applied to the data models. Some common validation rules include 1. Data type validation. Pydantic ensures that the data matches the specified data type, such as strings, integers, booleans, etc. 2. Length validation. Pydantic allows you to specify minimum and maximum lengths for string fields, ensuring that the data falls within the specified range. 3. Value range validation. You can define minimum and maximum values for numeric fields, ensuring that the data falls within the specified range. 4. Regular expression validation. Pydantic supports regular expression-based pattern matching for string fields, allowing you to validate data based on a specific pattern. 5. Enum validation. By using enumerations, Pydantic can validate that the data matches one of the predefined values. 6. Custom validation. Pydantic allows you to define custom validation functions for more complex validation scenarios. These functions can perform custom checks on the data and raise validation errors if the data doesn't meet the desired criteria. These validation rules help ensure that the data provided to a Pydantic model is valid and meets the expected criteria. If any validation rule fails, Pydantic raises a validation error, indicating which field S failed the validation.
Thank you for providing a clear explanation of how Pydantic handles data validation and the types of validation rules that can be applied. I'm interested in learning more about the integration of Pydantic with other libraries and frameworks. How can Pydantic be integrated with other tools, and what are some examples of popular integrations?
Pydantic can be easily integrated with other tools and frameworks in the Python ecosystem. It has a flexible design that allows it to work seamlessly with different components of a software stack. One popular integration is with web frameworks like Fastapi and Django. Pydantic can be used to define data models for request and response payloads, enabling automatic validation and serialization deserialization. This integration ensures that the data being sent and received by the web application is valid and adheres to the specified data structure. Pydantic can also be integrated with database libraries like SQAlchemy and TortoiseOrmDat. By defining Pydantic models that mirror the database schema, developers can perform automatic data validation when interacting with the database. This integration helps maintain data integrity and reduces the chances of errors caused by incorrect data. Another popular integration is with data serialization libraries like JSON and YAML. Pydantic models can be used to easily convert data to and from these formats, making it effortless to work with different data sources and formats. These integrations showcase the versatility of Pydantic and its ability to seamlessly fit into different components of a software system, making it a powerful tool for data validation and management.
Thank you for providing examples of popular integrations of Pydantic with other libraries and frameworks. It's impressive to see how Pydantic can seamlessly integrate into different components of a software stack. I'm curious about the performance impact of using Pydantic in Python applications. Does Pydantic have any performance considerations? And are there any strategies or best practices to optimize the use of Pydantic for better performance?
Yes, there are performance considerations when using Pydantic in Python applications. While Pydantic is generally efficient, there are some strategies and best practices that can be implemented to optimize its use for better performance. One important consideration is to avoid creating overly complex models or implementing excessive custom validation. This can have a negative impact on performance. It's important to optimize models for the best balance between validation rigor and performance. Another strategy is to leverage Pydantic's built-in validation as much as possible and use custom validators only when necessary. Pydantic's built-in validation is usually sufficient for most use cases and is more optimized for performance. Additionally, it is important to understand how Pydantic handles type conversion. In some cases, Pydantic might silently convert data types, which could lead to unexpected behavior. Being aware of this and handling type conversion appropriately can help improve performance. Overall, by following these best practices and being mindful of performance implications, developers can optimize their use of Pydantic and achieve better performance in their Python application.
Thank you for providing strategies and best practices to optimize the use of Pydantic for better performance. It's valuable to know that by carefully designing models, leveraging built-in validation, and being aware of type conversion, developers can achieve better performance in their Python applications using Pydantic. Now, I would like to ask about the future development and enhancements of Pydantic. Can you provide any information about the roadmap for Pydantic? What can we expect in terms of future updates and improvements?